Hello and welcome to the Forces Show, where we're going to talk about physics and, well, we're going to do physics problems too. All right, so here we're going to talk about how to do a basic net force equation and how to actually solve for some numbers when we draw our force diagrams. So we're going to be analyzing, again, Wonder Woman kicking Superman right in the face. So first things first, got to pick an awesome color. Let's just do that. So we got to pick our system, and we're going to look at Wonder Woman. And if you watch the previous video, we're going to make the same assumption that she's in contact with the ground down here. But we're not going to search any further on the internet to try and find that exact picture, because I already looked. All right, so now we got to draw a force diagram. So our system is Wonder Woman. So Wonder Woman. And we have to ask ourselves what forces are acting on her. So first of all, she's touching the ground, and the ground is keeping her from falling. So that what is going on? Computer. Sorry, technical glitch. Again, the floor is pushing up on her. So we have a force normal because of the push on Wonder Woman by the ground. And then gravity is pulling down on her because that's what gravity does. So we have force of gravity on Wonder Woman by the earth. And then she is kicking Superman here, so that means Superman's actually pushing back on her. All right, so we have force normal on Wonder Woman by Superman. And so it depends on how we analyze the system. If we say that she is at rest or constant velocity, then we're going to have balanced forces. But if we say she's accelerating, we'll have unbalanced forces. So for the sake of our argument, we're just going to assume that she's got balanced forces. So she holds her ground while she kicks him. So we don't experience acceleration. So that means that we have to have a second force to counteract this one. And that force is going to be friction by the ground. So force friction on Wonder Woman by the ground. So again, ground is applying both the normal force up and friction sideways. And then since we had the assumption that she is traveling at a constant velocity in all planes, both the x and the y, we have to show that by marking that on our force diagram with tick marks. All right, so this is our force diagram. So now we're going to analyze it using a net force equation. So the way I write my net force equation is this. All right, and I'll do it below here. Let's pick a different color. Tyler, my co-host. Tyler, say hi. Oh, he's being hi. He says hi really quietly. All right, so this is how I write the net force equation. Sum of the forces, and then something equals 0. So this says sum of all the, it's addition. It's from math, and then F is just forces. F-O-R-C-E-S, good spelling. And then this blank spot here, this is where I'd put the X or Y. So I talk about a specific plane that I'm examining. And then equal to 0, and the reason why it's equal to 0 is because they are balanced. So if this is BAL, why can't I write today? If this is unbalanced, then it's not equal to 0, and we'll talk about that later on. But for our situation, we're going to say they're balanced, so they're always going to equal to 0, because if you have this value pulling to the right, that'd be a positive. This value pulling to the left, that'd be a negative. And we said they're equal, so it's like a positive 5 plus a negative 5 equals 0. Okay? So this equation only works equaling 0 if all the forces are balanced in that plane. So I'm going to do one for each plane. So let's pick a new color. Let's go with red. All right, so I'm going to start with the x-plane. So sum of the forces in the x-plane equals 0. So I have two forces. So I have a negative force normal plus a positive force of friction. Notice I can write this in any order I want because it's addition, so order is irrelevant. But the normal force is, what am I doing? Oh my gosh. Have you ever just had one of those days? Doot doot. Oh, you can see, this is why I let you guys make fun of me, because I screw up all the time. The normal force is going to the right, so it's positive. And then this is actually plus a negative force of friction because friction is negative. So for all those you playing the at-home remembering game, up and to the right is positive, left and down is considered negative, unless there's some specific changes that you want to make. So these two forces added together equal 0. So now, in order to solve this, we need some numbers. So let's assume that Wonder Woman can kick with a force of 10,000 newtons, all right, which is like 2 tons. And if she's hitting Superman with a force of 10,000 newtons, that means Superman is also applying the exact same force to her of 10,000 newtons, because two objects interacting create one force. So let's just say this is 10,000 newtons. All right, that's the force normal on Wonder Woman by Superman, because that's how hard she kicked Superman. So when I go to do my math, this normal force can become 10,000 newtons. So then minus the force of friction equals 0. So we can figure out what force of friction would have to act on her to make this work. So that's pretty simple math. So then force of friction is also equal to 10,000 newtons, which, by the way, is totally impossible. But hey, there's superheroes and comic books, so I don't expect the physics to be exactly spot on. All right, so that's the x-plane, but we can do the exact same thing in the y-plane. So I'm going to do that again. So I'm going to sum the forces in the y-plane and set that equal to 0, because we said in the y-plane the forces are also balanced. Well, in the y-plane, we've got the force normal pointing up, so it's positive, then minus, aka plus a negative, the force of gravity, because gravity is pulling us down, so that equals 0. And now, from our lab experiences, we actually have an equation for the force of gravity. So force normal minus mg equals 0, because we discovered through some lab experiments that Fg is the same idea as the force of gravity. So we said Fg equals mg from our lab. So that's where that's coming from. So if I want to figure out the normal force, really all I got to do is figure out G, aka what planet are they on, and then M, what's the mass of Wonder Woman. Now I know she doesn't tell, but I'm going to just give her a random mass. I'm going to say that her mass, Wonder Woman has a mass of 70 kilograms, because I think that she's kind of muscular and can kick some butt. So I'm just going to say 70 kilograms. All right. So I can do some substitution, and that's not what I wanted to do. There we go. And so I can say, well, the normal force minus her mass of 70 kilograms times the g, because I'm going to say they're on Earth, so that's 9.8 on Earth, equals 0. So now I can do this math and figure out the normal force is 686 newtons. So this is the fundamental way that you solve for any unknowns, any forces, or you could solve for a mass if I knew the force, because you can see how if I knew the normal force, I could solve for the mass, or if I knew the normal force and the mass, I could solve for, like, hey, they're on a random planet. What's the gravitational field strength of that planet? I could solve for any of those things using the exact same methods. But notice how I kept my x's and my y's separate of each other. All right, I can look at them totally independently. So this is how we solve net force problems. All right, so I hope that was fun for you. Let's go back to reading more comic books.